Welcome back, Algebros. We return to the main document where we talk about our answer. Last time we did a GeoGebra adventure, and we got to see how adding or subtracting or multiplying different terms in and around our core function really changed how it interacted on the graph. Here, in order to go through this demo a little bit more in detail, we're going to transform through Dotson. He's our function. In the GeoGebra adventure, Dotson was being demonstrated through x squared as the base. But in this case, you're going to see a black dot, as you do see here, and that's going to be the general case for all kinds of functions, not just x squared. So if you see anything else that doesn't look very familiar, it's just a function as if the grand machine were set that way. But instead of putting silly hats or funny clown shoes or fancy sunglasses, this time it could be squaring numbers, it could be finding the square root, or it could be doing some wild and crazy trigonometry thing. The details aren't necessarily important yet, but they are cool to know, and I would encourage you guys to experiment with some graphing software to know what's going on. Let's start off with the first thing we saw, vertical shifts, which we can title, right here, vertical shift. We've generalized the outside term being added as k. K being any real number. K causes the curve to shift up or down. If k is positive, which is what this means right here, then it will shift up. If k is negative, which is what less than 0 means, it will shift down, which is what we saw before. However, if k is 0, then we'll have no vertical shift. Let's look at these examples over here. For f of x equals x squared plus 5. X squared looks something like this. So if we're adding 5 to the outside of it, not to the inside, that's the importance of the k being out here. It's not being added inside Dotson, it's being added outside him. So that means that this entire curve is going to go up by 5. So to fill in these blanks, f shifts up by 5. Similarly, don't let this square root sign on the x confuse you. If you want a little bit of a general know-how, the square root of x looks something like that, like a little bit of an arm reaching forward. And if it's getting 4 subtracted from the outside, much like we saw with the quadratic, it's going to move down by 4. F in this case will shift down by 4. Note this does not shift down by negative 4. Just take the absolute value in terms of how many spaces it's moving. Finally, cosine of x. It's one of those wavy line ones that we've seen before. Again, trigonometry. You'll see that later. And if it's getting 10 added to the outside of it, it's going to go up by 10 spaces. So it'll shift up, since 10 is positive, by 10. Pretty awesome. As a little bit of an exercise for you, try to shift x squared by 15. How would you do that? Moving on, we now talk about what happens when you're trying to do some sort of operation inside Dotson. So this is inside of him. It's affecting the input before the action is placed on it. And this number h right here is once again any real number. We also note in the general structure that there's a minus sign right here. This impacts some of the opposite day syndrome we might have had when we were on the GeoGebra adventure. H causes the curve to shift right or left, but note how I talk about h being positive or negative in here. When you see the minus sign on h, that's as if h is positive. So you can put a little bit of a note right here that when h is positive, you're going to see x minus h. Or, if h is negative, you're going to see x plus h. Because if h on its own, without the minus sign, is a positive value, it's going to stay x minus h. So for example, if h were 7, then x minus h, if we replace h by 7, is going to be x minus 7. Same, if h were, say, negative 3, then x minus h will be x minus negative 3, which is just x plus 3. And as before with k, if h is 0, we have no horizontal shift. Let's go back here. A couple more examples. For the square root example, once again, it looks like this little arm reaching over right here. But this time, the minus 2 is happening from within. It's happening before we apply the square root. So in this case, since it's x minus h in this case, it's this situation here. So we're going to move to the right by the number we're dealing with is 2. So it's by 2 spaces. Next, sine of the stuff. Once again, another one of those curvy, wavy, oscillating lines. In the same way this time, the 6 is being added inside, before sine of x takes effect. So once again, this is a shift. But it looks like the negative one this time, because we have the plus. So here, h is negative, so f will shift, instead of right, we'll shift left by 6. It's going to take some getting used to, but I know you can do it. Finally, in this last one right here for f of x equals x plus 10 cubed, in this case right here, I have this 10 being added from within. But since it's in the form x plus h, this means that h is negative. Therefore, f will shift left once again, this time by 10. Returning back to x squared, using GeoGebra, what will happen if I had something, say, like x minus 7 all squared? Similarly, what will happen if I have something like x plus 1 squared? I leave that as an exercise for you. We'll talk about it in class.